Part 1. The basic functions of calculator. Hi, I'm now going to introduce you the basic functions of our HP Financial Calculator version 10b2 Plus. This is a keyboard map legend. Firstly, we have our 12-character 7-segment screen display. We have various annunciators appear around the screen when the functions are activated. For example, RAD, semi, and input. The slide shows the keyboard map legend, which shows the functions of the key buttons. It is also available in the calculator manual. I suggest you to spend some time looking into the map to familiarize yourself with the keys. When using calculator, if you happen to forget where is the key or what key function to use, this map can provide you with the first direction. Let's get started with the overview. First of all, to turn on the calculator, press the on button, which is the leftmost button of the bottom row. As you may have already noticed, each of the calculator key buttons has 3 different colors of wording representing 3 different functionalities. White keys are the primary function of the calculator. We also have the orange functions, which sits below the white keys, and blue functions which sit on top of the white keys. They are the secondary functions of the calculator, and to reach that, you need to use the shift keys. We have shift up blue key and shift down orange key. This calculator is operated by 2 different modes, algebraic and chain mode. The difference between algebraic and chain mode is that algebraic mode follows BODMAS, the brackets of division, multiplication, addition, and subtraction, whereas chain mode doesn't. So hereby, I suggest you all to use the algebraic mode, and the remaining part of the video will all be on algebraic mode. So to toggle between algebraic and chain mode, these are the keys. In your calculator, you can find algebraic/chain blue function right on top of the on key button. To toggle between these 2 different modes, press shift up and on. Now you will see the word algebraic flashes on the screen. It means that the calculator is operating at algebraic mode. If it says chain, it means that the calculator is set in chain mode. Alternatively, you can also check the mode using RCL recall function. RCL function or RCL button is located right here in your calculator. So press recall, shift up and on to recall the mode that the calculator is currently operating at. And the screen displays algebraic, means that the calculator is in algebraic mode. Changing decimal places. The current display on my calculator here shows 2 decimal places. It means that whatever calculation performed using this calculator, it will automatically round the answer up to 2 decimal points for you, which may be carried forward to the next calculation. So to avoid rounding issue, I strongly suggest you to change it to at least 4 or 5 decimal places. So to change from 2 decimal points into, say, 5 decimal places, you will find the DISP orange function sitting below the equal button. So to get that, press Shift down, then equal, then number 5, because we are changing the decimal places into 5 decimal points. Next, interchanging between period and comma. I start with an example. 1 million can actually be displayed as this or that. Where the first display, we have the comma as the digit separator and the period as the decimal point. And for the second display, we have the other way around. So this is the difference between the US display and the international display. In other words, they are the same. It is just a matter of different display of a number. Because we are more used to the first display, and if it happens that you have different display, do not panic. You just need to switch between the period and comma. And the orange function below the dot button in your calculator allows you to toggle between these options. So press Shift down and the dot button to toggle between these options. Lastly, to turn off the calculator, you will see the off orange wording below the on button. So press Shift down and on button to off the calculator. Now we have some extra features and settings to be mindful of. Firstly, all instructions in your calculator manual are all in chain mode. And what I'm demonstrating here are all in algebraic mode. So this is not a big deal because the difference between algebraic and chain mode we all know is that algebraic follows BODMAS while chain mode doesn't. So if the calculator has already been set into algebraic mode, it has no effect whatsoever if we follow an operation in the chain mode. E notation. It represents the scientific notation of 10 to the power. So calculator only display 12 characters. Any number greater than 12 characters will be displayed in scientific notation with the letter of E. For example, 9.3 E17 means 9.3 multiplied by 10 to the power of 17. And 9.3 E negative 17 means that it is 9.3 multiplied by 10 to the power of negative 17. If a calculation hasn't been completed yet, so for example, we need to calculate an expression 3 times 2. So 3 times 2. So before we key in the next number, we will see the PEND pen annunciator displayed at the bottom right hand side of the screen. That represents that the calculator is pending a calculation to be completed. Similarly, if you want to start a new calculation, you need to make sure that the pen annunciator does not display. Next, to backspace one digit at a time, we have the backspace key, which is located here in your calculator. And to clear the whole entry, press the C button here. And we will talk more about clearing buttons in a minute. So we have here the pocket dialing checklist before a calculation. So before you start a new calculation, first of all, you need to make sure that all unnecessary enunciator should be cleared or not displayed, except some mode functions which are required for your calculation. Ensure your calculator is in algebraic mode. Please recall how to check whether the calculator is in algebraic or chain mode. Lastly, before a new calculation, it is also very important to clear all or required memories, which we were going to talk about in the next slide. As mentioned before, C button clears the entry that is currently displayed on screen. However, it will not clear the memory of the last calculations or the memory of the series of numbers that you have stored into the memory of the calculator. And yes, the calculator can store number, and we will look into that later. Next, we have CMem. So this is to clear the memory of the calculator functions. So CMEM with a number 7 clears the bond memory as it says here. To get that, you need a shift up key plus the C button to get to C memory. And with number 7, once cleared, the message of bond cleared will flash up on screen. So C memory 4 clears the break-even memory. And the message of break-even cleared will flash. C memory 1 clears the time value of money memory, and C memory 0 clears the cash flow memory, and their corresponding message will flash up on screen after the memory has been cleared. CStat clears the statistics memory, which is located in the middle of the calculator as the orange function. So shift down key is needed before that. And lastly, we have CAll. That is to clear all the memory. You will find CAll as an orange function right under C button. So press shift down and C to clear all the memory. Now, let's get started with the general arithmetic with one number functions. First of all, we have our basic mathematics operators, addition, subtraction, multiplication, and division buttons right here in your calculator. So, once again, set your calculator in algebraic mode. And to check that, use the recall function Shift up and on to check the mode. Please note that we have a plus/minus key in our calculator right here. This is a change of sign, which is different from the minus key. And we also have other signs and operators such as exponential, which is located as the orange function below 1, logarithm, which is located as the orange function below 2. We have the percentages, we have the square root, we have square, we have inverse, and we also have y to the power of x. For these operators, number needs to be entered first, then the operator. We will look into some examples in the next slide. So for the first example, what is the 10th root of 256? So this is equivalent to 256 to the power of 110. In this example, we are going to use two different operators, which are y to the power of x, that is to cover 256 to the power of 110. And then the second operator is the inverse function, that is to cover 1 over 10. First, we press 256 to the power of. Now you will see the PEND, pen enunciator, appear. Then we need to inverse the number 10, make it into 1 over 10. So we press 10, then inverse. And the display will show the result of 1 over 10, which is 0.1. Then to complete the calculation, press equal. And the answer is 1.7411. Second example, exponential 3. First, the number has to be entered first. 3. Then the exponential. And the final answer is 20.08554. In the last example, we have ln 1.56, and same thing, 1.56, then log, and the final answer is 0.44469. Now, I would like you to pause the video and try the following calculations at your own. Next, I will bring you through the general arithmetic for multi-number functions. We have three different approaches: nested parentheses using the brackets in the calculation, using the basic memory key buttons, and using the last memory recall button. I will bring you through each of them one by one with some guided examples and some pause you try examples in each of the following sections. In algebraic mode, multiplication and division have a higher priority than addition and subtraction. We use parentheses or brackets in our calculations to postpone calculating an intermediate result until you have entered more numbers. One very important thing that you need to bear in mind is that this calculator can only allows you to use up to 4 open parentheses in each calculation. Now, example, suppose we want to calculate this expression. So first of all, I clear all my memory. If you enter 2 plus 3 divided by 5 minus, before I put into the last digit, the calculator displays the intermediate result, which is 2.6. And we all know that this is incorrect. This is because the calculations without parentheses or brackets are performed from the left to the right hand side as you entered them. To delay the division, we therefore need to use the parentheses or the brackets. And because the calculator will not display the brackets that you have keyed in, sometimes for a complicated operation with more than one open parenthesis, it is hard to visualize how many open brackets have been inputted and how many closed brackets you need to complete the calculation. So my suggestion is to rewrite the expression into one line with the corresponding brackets. Then press the number into the calculator with the brackets accordingly. And the open and closing brackets buttons are situated below the RM and M plus buttons. So we clear all our memory and we start that again. So we have the one line operation here, so we key in accordingly. Open bracket 2 plus 3, close the bracket, divided by open bracket 5 minus 2, close bracket, equal. And our final answer is 1.67. Now, please pause the video and try the following examples using nested parentheses. Before we go into the next section using the memory key functions, let's try a more complicated example using parentheses. This is our example here. So first of all, we write the expression into one line as what I've written here. Then enter the numbers and brackets into the calculator accordingly. So first of all, before I start my calculation, I clear all my memory. And we start by 10 squared divided by open bracket 2 times 5 plus second open bracket 2 times 80 divided by 4, closing bracket, equal. and the final answer is 2. Please also note that the closing parenthesis at the end of the expression can also be omitted. So in the left hand side, we have the open and closing parenthesis, and in the right hand side, we only have the open brackets without the closing parenthesis, and it works in our calculator as well. Okay, let's move on to the next approach using basic memory keys. These are the keys that we are going to explore in this approach. They are located right here in your calculator. So you need to first understand the functions of each keys. Arrow M stores a figure into a memory. M plus key adds a new figure into the same memory, and it will total up the number with the previous numbers that you have stored. RM key recalls the figure stored in the memory. Now, let me show you some examples that we can use the memory key buttons to compute for the answer. First, very simple example. Before we start a new calculation, please remember to clear all the memory. And in this example, we start with the denominator. 5 times 2 plus 3 equals to 13. And we are going to store this figure into a new memory. So we need to press on the arrow M. Then we compute the numerator. 2 plus 3 equals 5. And we need to divide this number 5 with the number that we previously stored into the memory. So we press division button and RM to recall the number. Once we press RM, it brings up the figure, which is 13. Then press equal gives us the final answer. And the final answer for the first example is 0.38462. In the next example, first of all, we need to clear our memory. And same thing, we need to start with the denominator. 5 times 2 equals 10. And we store it into the new memory by clicking arrow M. Then we have 3 cubes here. So 3 to the power of 3 equal 27. And we are going to store it into the existing memory. And we need to add them up. So M plus adds the value into the memory. Then for the numerator, 2 plus 3 equal, and divide this number with the previous stored figures. So we press RM and it will bring up the previous stored figures. Then equal gives us the final answer. And the answer for this example is 0.13514. Now, Please note that in this example, the denominator can actually be computed in one go. So 5 times 2 plus 3 to the power of 3. Since we are in algebraic mode, which follows BODMAS, so we separate the computation just now for illustration purposes. Now, please pause the video and try the following examples using basic memory usage. Again, before we go into the final approach, let's try the same question as previous approach, but now using the basic memory functions. So this is our example. We have in the denominator a multiplication plus a combination of multiplication and division. So we need to store the different figures into the memory and adds them up together. So we start from 2 times 5 equals 10, and we store it into the new memory, so arrow M. Then 2 times 80 divided by 4 equals 40, and we are going to add the 40 into the previous memory. So we click on the M plus. So now the figures becomes 50 in total. Lastly, the numerator. We have 10 square. And we need to divide this by the numbers in the memory. So RM. And once you press RM again, it brings up the figure in the memory, which is 50. Then equal to get the final answer. And the final answer of this example is 2. And please also note that the denominator can actually be computed in one go for the same reason, because the calculator is set to be in algebraic mode. If you are in a chain mode, you cannot solve the denominator in one go. I have shown you the way to compute multi-number functions using parentheses and memory usage. Now, let's try solving the functions using last answer, RCL function, and the equal buttons, which have the function of bringing up the last calculation or the last answer. Applying the same example again, as I mentioned before, we can perform the denominator in one go because the calculator is set to be in algebraic mode. So we can input the numbers and operations straight away in one go. 2 times 5 plus 2 times 80 divided by 4. And we get the answer 50. Without storing this number into memory, when the calculation is completed by pressing the equal button, or the calculation is completed during another operation, the result is stored automatically in a memory location that contains the last calculated result. This enables the last result of a calculation to be used during the subsequent computation. And to access the last calculated answer, we use the RCL and the equal buttons. So we have done the denominator, And without storing this into any of the memory, we can perform the numerator straight away. 10 squared and then divided by the last answer, RCL equal. That brings up the last calculated answer, which is 50. And to complete the whole example, we press equal again, and the final answer is 2. So unlike the other stored memory registers, this register is automatically updated when you complete a calculation. Alright, that's the end of part 1, and I really hope that you have mastered the basic function of our calculator by now. Next up, we will be looking into the finance functions of the calculator, and we'll also be trying some TVM, time value of money, and bond valuation problems using these finance functions. Thank you.